I'm Kaeini. We are going to start the second lesson on the differentiation. This is about the tangent line and normal line to the curve and chain rule. Now, first we discuss about the tangent line. What is tangent line? Yeah, we have discussed this when we are talking about the first principle differentiation. We define the gradient of the curve as the gradient of the tangent line to the curve. Therefore, gradient of the tangent line at any point on the curve is the gradient of the curve at that point. So whenever you want to draw a tangent line to the curve, you need to find the gradient. It's sufficient to find dy by dx at that point. Okay, it's very important to remember at that point. Okay, now you know that when you are writing an equation of any line, you need the gradient of the line and a point. You need all these things, so you can write the equation of the line. You can use either y equal to mx plus c, which m is the gradient, which you are finding from using differentiation, and c is the y-intercept. You can find it using the point. Or you can write this formula, which I like it more, y minus y1 equal to m times x minus x1, which is m is the gradient, and x1 and y1 is the point. So we can write the equation of the line. Okay, now let us see what is the example here. Write the equation of a tangent line to the curve, y equal to x cubed minus 5x squared plus 6x minus 3 at x equal to 2. So what we need to do is that we need to find dy by dx, therefore we are getting the gradient, and we need to find the y, so we have the point. Now, dy by dx gradient of this function will be 3x squared minus 10x plus 6. Therefore, this is the gradient at all points. It's the gradient function. You want the gradient at x equal to 2. Therefore, at x equal to 2, dy by dx will be, you have to substitute 2 here. 2 squared is 4, 4 times 3 is 12, 2 times 10 is negative 20, and 6 is itself. So if you simplify this, you are going to get negative 2. So now after this, we are going to find the y value. Therefore, the gradient of the curve is negative 2, so that the gradient of the tangent line is also negative 2. That we discussed. Now, at x equal to 2, you can find the y value. Therefore, 2, you have to substitute here to get y value. Okay. 2 to the power of 3 will be 8, minus 2 to the power of 2 is 4. 4 times 5 is 20. And 2 times 6 is 12 minus 3. Therefore, you can just simplify this and get negative 3. Therefore, the point is 2 and negative 3. Now you can use the formula y minus y1 equal to m times x minus x1. So you can substitute m is negative 2, y1 is negative 3, and this is 2. So y minus negative 3 is equal to negative 2 times x. So you can simplify this easily. Then you can get y equal to minus 2x plus 1. Therefore, this is the equation of the tangent line to this curve at x equal to 2. Okay, now let us see what is the next example. Okay, now the function has been given to us. We want the equation of the tangent line to the curve at x equal to 2. And then again, let's see what we are doing. Perhaps you can find y. dy by dx, we are getting the first space, we are going to get the gradient. This is 2x minus 5, just substitute x2 here, therefore you are going to get negative 1. This is your gradient of the tangent line. Therefore, now you need the y value, therefore you need the y value at x equal to 2. Therefore, y will be 2 squared minus 10 plus 5, just substituting 2 here. Easily you can get negative 5. Now you have the gradient and you have the point. You can write the equation y minus negative 5 is equal to negative 1 times x minus 2. You can simplify this. You are going to get x minus y equal to negative x minus 3. So here there is something which I would like to make a note of, that this is, when we are using this till now, always this n was an integer, a positive integer, but this n need not be a positive integer. It can be any kind of number, can be a fraction, or can be a negative number. So this can be extended for all the values of n. Therefore, can be used for any value of n. Therefore, now suppose we want to differentiate this. Now look at this function. Actually, this function, if you write it in the exponential format, x is to power of half here, x is to power of half here, and here x is to the power of -1 because it is in the denominator. Therefore, you can write this in this format. Now you can see this in this format. You can differentiate. Therefore, this 1 comes down, dy by dx. This 1 comes down. Reduce 1 from here. Therefore, half minus 1 will be -half. This -1 comes down here, will be negative. To power of -1, -1, minus 1, -1 minus 1 will be -2. Therefore, the derivative of this function is this. Now, equation of the tangent line to the curve y equal to 2x square root of x at x equal to 4. Now, to do this, first of all, I prefer to write this in this format. That means I want to write it in the exponential format, in the power format. I don't want to have it in the square format like this. Therefore, I am saying this is 2x and this is x to power of half. We know that if the base are same, you have to add the powers. Therefore, here the power is 1, here is power half. 1 plus half is 3/2. Therefore, your function changes to 2x to power of 3/2. These function here and this function are exactly the same. But this now you can use this formula to differentiate. Therefore, you can say that dy by dx, this 2 is constant, 3/2 comes down, okay, and reduce 1 from the power. Therefore, 3/2 minus 1. 3/2 minus 1 is actually half. So these two cancel these two. You are going to get dy by dx equal 3. X to the power of half, you can write it as square root of x if you prefer. That is your choice. Therefore, it doesn't matter either in this format or in this format. Therefore, it is dy by dx. Now, if I want to find the gradient, I have to put it at x equal to 4. So at x equal to 4, therefore, dy by dx will be 3 square root of 4. 3 square root of 4 is 2. 2 times 3 is 6. Okay, therefore, the gradient of this function at x equal to 4 is 6. And so the gradient of the tangent line. Now, look at this. Now we are going to find the y value. Y value, I am just substituting here. You can substitute here as you wish. Therefore, 2 times 4 times the square root of 4. The square root of 4 is 2. 2 times 4 is 8. 8 times 2 is 16. Therefore, y value is 16. Therefore, x value is 4. Y value is 16. Now, simply I can use my formula. Y minus 16 is equal to m, which is 6, times 6 minus 4. Just you can expand and bring this side. That is very simple manipulation of algebra. Therefore, this is y is equal to 6x minus 8. Therefore, we got the equation of the tangent line to this curve as well. Now, let us look at this and see. Now, what is the normal to the curve? Look at this graph here. We have a graph and we have a green line here. Green line is a tangent to the curve at the point P. Therefore, this is the tangent of the curve at the point P. Now, the line which is perpendicular to this, which is the blue color here, is normal at this point. Okay, therefore, normal to the curve at any point is perpendicular to the tangent line at that point. Therefore, this is the definition of the normal to the curve. Normal to a curve at a point is the line which is perpendicular to the tangent line at that point. Same as this blue line, which is perpendicular to this green line here. So this is the tangent line, and the blue one is the normal line. Therefore, now, we know that two lines with the gradient m1 and m2 are perpendicular if m1 times m2 is equal to -1. That means if you have m1, you want to find m2, you have to put a negative sign and inverse it. Find the reciprocal of that. Reciprocal of that, and then you put a negative sign. So you are going to get the other. Okay, now find the equation of the normal to the curve y equal to x plus square root of x at x equal to 1. Now, at x equal to 1, first of all, we are finding y value. Just substitute 1 here. 1 plus the square root of 1. Square root of 1 is 1. Therefore, this is 2. Therefore, the point is 1 and 2. Now, we need to find dy by dx. For finding dy by dx, we know that y, here, the derivative of this is 1. And we know that this is x to the power of half. Therefore, half comes down. reduce 1 from the half. Therefore, half minus 1 is actually negative half. Therefore, half minus 1 is negative half. Therefore, this is the gradient function. But x is equal to 1, since x is equal to 1, so at x equal to 1, 1 to any power is 1, 1 times half is half, therefore the answer is 1 plus half, which is 3 over 2. Therefore, this is the gradient of the tangent line. Therefore, this is gradient of the tangent line. If you want to find the gradient of the normal, just find the reciprocal of this, inverse it, flip it, or whatever you can say. 2 goes up, 3 comes down, and then put a negative sign. That means m1, this time this will be negative 1. Therefore, m1 times m2 will be negative 1. Therefore, this is the gradient of the normal. Therefore, now you have the point, you have the gradient. As usual, you can write y minus 2 is equal to m times x minus x1. 1 is also x1 is 1. Okay, then just simplify this. Easily you can see that your answer is y equal to minus 2 over 3x plus 8 over 3. Now let us see what is the next example. Now we have a function y equal to 2x cubed plus 2x squared minus 3x. Sketch below, therefore, now I will give, okay, this is the graph of the function, therefore this is the graph of this function. And we know that this is the tangent to the curve and this is the normal to the curve. And it says that this is at here, x is equal to negative 1. At the point A, with the x coordinate negative 1, write the equation of the tangent and normal. Therefore, the first we have to write the equation of tangent and equation of normal. And then he's asking to find the area of this triangle ABC. Okay, to find this. Now, let us go. This is actually an exercise for you. And I am going to just give the answers here to you so you can try it by yourself. See, now, x is equal to negative 1, just substitute here. If you substitute here, you are going to get y equal to 3. Therefore, y is 3. Therefore, the point is negative 1 and 3. This is the point A. Okay, now after that, you need to find dy by dx. dy by dx will be 6x plus 4, 6x squared plus 4x minus 3. Now you have to substitute negative 1. If you substitute negative 1, you are going to get negative 1 again. Therefore, you are substituting x equal to negative 1. Therefore, dy by dx will be negative 1, which is your m. Sorry. Negative of that will be 1. Reciprocal of 1 is 1. Therefore, m2, which is the gradient of the normal, will be 2. Therefore, you are going to get this. Now, after this, the equation of the tangent, very simply, you can write it because m is negative 1, therefore negative x here, therefore this is also your point, therefore you are going to get y equal to minus x plus 2. Therefore, equation of the tangent, equation of the normal will be y equal to x because the gradient is 1, and it is supposed to pass through this point, therefore you are going to get x plus 4. So, now, to find the point B and the point C is sufficient to put y equal to 0 in these two equations. If you are putting y equals to 0 in this equation, you are going to get x equal to 2, therefore this is this. And if you are putting y equal to 0 here, you are going to get x equal to negative 4, which is this. Therefore, you are getting these 2 points. Now you want to find the area of this triangle. You know that the area of triangle is height times base divided by 2, or half times height times base. Okay, from B to C, we know this is negative 4, and this is 2, therefore BC is 6, and this is actually y coordinate of the point A, which is 3. Therefore, the answer for the area will be equal to half 6 times 3, which is 9. Therefore, this is very briefly all the answers I've given here. You try by yourself and check your answers. Therefore, the working is with you. Okay, now let's go for the chain rule. What is chain rule? Now let me put back this there. Now let us see what is chain rule here. Now, suppose you have a function y which is defined under a variable u, where u is a function of x. Therefore, there are a function which is depend on u, where u itself is a function of x. Now you want to find dy by dx. Finding dy by du, okay, you can find easily dy by du, which is here. And then if you multiply this by du by dx, actually it seems that this will cancel off this. you are going to get dy by dx. Therefore, you are finding change of y with respect to change of x and multiplying by change of u divided by change of x. Therefore, this is called chain rule. Now let us see how this can be used. Suppose y is equal to u squared and u is equal to x squared plus x plus 1. Therefore, you know that this y, your function f, is depend on u, and u itself is depend on x. Therefore, when x changes, u changes. When u changes, y changes. Now you want to find change of y with respect to change of x. Now let us see what is the question says. First, he's asking us to find dy by du, and then he's asking find du by dx. Then he's asking us to find dy by dx. Then he's asking find y in terms of x, and then again find dy by dx. Okay, let's go one by one. Now, here we are saying y is depend on u, therefore change of y divided by change of x will be 2u as usual. 2u, 2 comes down, reduce 1 from the power, 2u. Now, to find du by dx, therefore du by dx, therefore this is u, this is x, therefore again will be 2x plus 1, therefore this is also done. Now, if I multiply these two together, I'm going to get dy by dx. dy by dx is this times this, therefore this is 2u times 2x plus 1. You remember that. So I told you dy by dx is equal to dy by du times du by dx. Okay, then you're multiplying these two. And what is u? U is, if you want to write in terms of x, u is this. Now, okay, the answer is done, but for you to understand what's happening, then I'm just expanded this, I got this answer here. Okay, this is dy by dx after simplification. Okay, now, finding y in terms of x. Now you are saying u is this. I can substitute this u here and say y is actually equal to this to the power of 2. If you expand this, you are going to get this expression. Now you can directly find dy by dx because now y is in terms of x. There is no u anymore. Therefore, you are just simply differentiating. You are going to get the same answer. You can see that the answers are same. So, doesn't matter which way you are going, but sometimes this is complicated and you cannot do it easily, so that you have to use chain rule. Okay, let's see. Now, suppose you want to differentiate this function here. Actually, you can assume that this is u to the power of half. So this is your u. So when you are differentiating this half comes down, reduce 1 from the power, and then du by dx. du by dx is this, 2x plus 4. Try to understand what we are doing. Actually, it is u to the power of half. Therefore, half comes down, reduce 1 from the power. Therefore, this is done. And then you have to write du by dx. du by dx is 2x plus 4. Therefore, whenever you are having power, an expression to power of something, therefore, you should use the power rule multiplied by the differentiation of the base. Differentiation of the base. Therefore, this is very important thing which we are using it very often. Therefore, suppose if we are asking differentiate this, therefore this is actually 7 comes down, reduce 1 from the power. Therefore, this is 6. Now this is u to the power of 6. Now we have to differentiate this one here. Differentiate this one here will be 9x squared minus 18x plus 5. Therefore, there is no power here. This is du by dx. U is this. Expression in the bracket is u. Therefore, this is du by dx. So you are finding the derivative of this function. Therefore, remember when there is power comes down, reduce 1 from the power, then multiply by derivative of the base of your u. Okay. Now, let us see, we can do this question here. A very simple question. It's asking us find the equation of the tangent line to the curve, so and so, at the point x equal to 2 on the curve. Therefore, x is 2 on this curve. Okay. Now let us see what is the solution. If you like to do this by yourself, you can pause the video and do the question, and later on we can compare your answer with the solution which I'm going to give. Okay. Now, let us see. Find the value of y. Therefore, put x equal to 2. At x equal to 2, y will be equal to a square root of 2 squared is 4 plus 2 plus 3, which is 9. A square root of 9 is 3. So the point is 2 and 3. Therefore, we have got the point. Now we need to differentiate this. You remember this is something to the power of half. Okay. This is to power of half. When this is to power of half, the half comes down and reduce 1 from the power. Don't forget, you have to multiply by the derivative of the base. That is your u actually. Therefore, you need to differentiate this part also. Therefore, 2x plus 1. Don't forget, there is no power here. Sometimes you are putting power half here, sometimes you are putting power negative half here. There is no power here. This is your u without any power. This is u. Okay? Therefore, you are finding du by dx, which is 2x plus 1. Therefore, this is the derivative of this function. Now you need to put x equal to 2. Okay, at x equal to 2, just substitute 2 here. Okay, that is very simple. This is actually 9 to power of negative half will be 1 over 3. Therefore, this is 1 over 3. This will be 6 times this will be 6. And this is actually 5 over 6. Therefore, the derivative of the function is 5 over 6. Now we want tangent. Therefore, this is the gradient of the tangent line. No need to find for the normal because he's asking only tangent line. Therefore, this is 5 over 6. Therefore, now I can use my formula y minus y1 equal to m times x minus x1. Therefore, y minus 3 equal to m 5 over 6 x minus, sorry, this is a mistake here. This is x minus 2 here. Should be x minus 2. Sorry, this is 2 here. Therefore, maybe this answer also is wrong. Okay, therefore, you do the correction here. This x minus 2.